Hello, everybody. My name is Stephen, and welcome to this episode of the BIM Tube podcast. Today, I'm joined with Tina Thomson. So, welcome, Tina. Thanks for joining me.
Thanks for having me.
And because we're both very busy in various different ways, it's taken us some time to arrange. So I'm glad we're here at last. So welcome. Thanks for joining me and taking the time. So today we're going to talk, for the benefit of people that haven't watched or listened to one of these podcasts before. It's based on better information management. That's what I mean by BIM. So we talk about digital data, decision-making, information management generally, and how it's applied. So we're not going to necessarily go into the ultra detail of technology and data. Other people can do that kind of podcast. I'm talking about the application of decision making with digital data. So Tina, before we go ahead anymore, if you wouldn't mind, if you would introduce yourself, your current role, and just maybe a little bit, if you don't mind, your career progression, because I'm really keen for people starting their career from different places that, you know, there's this convergence of digital and data at the moment. So if you wouldn't mind just a little bit of your career progression as well. So over to you, Tina.
Yeah, sure. Well, let's start off with where I'm at the moment. So I work at Gallagher Re, which is a reinsurance broker that basically supports insurance clients with purchasing reinsurance. So basically insurance for their business, hence why it's called reinsurance. So it's all about risk mitigation. And I work in the analytical space called catastrophe modeling, which has pretty much been the majority of my career. It's a very interesting field because you deal with natural weather phenomenon, earthquakes, floods, hurricanes, but also man-made catastrophes. If you think about cyber attacks, terrorism, that sort of thing. And it's all about insuring against this type of risk, how you can assess that type of risk and mitigate ultimately and quantify it. And that's where the analytical space comes into it. So currently I am leading the international catastrophe analytics, which covers the EMEAs, so Europe, Middle East and Africa, Asia Pacific, as well as Latin America and Caribbean. And also I am responsible for our Gallagher Research Centre, which is designed to bring in academic expertise in advising on the view of risk that we develop. We build our own in-house models, catastrophe models, and all of those models, they tie quite closely with academic research. If you think about climate modeling, for example, understanding the latest scientific methods, there's obviously a lot of statistical application in these models, and how we can, basically keep up to date with those developments. Particularly artificial intelligence is, I think, a bit of a sort of hot topic at the moment as well, and how that plays into catastrophe modeling. And yeah, generally speaking, it's a really interesting field for me to been staying connected with academic research. Given my background, to your question, I did do a PhD in geographic information science, and have been actually quite closely linked with the academic community in the UK throughout my career. I've been involved with learned societies like the Remote Sensing and Photogrammetry Society, as well as the Geographical Society. So I've always enjoyed working between sort of academia and industry, although I've never pursued a career as such in academia. So after my PhD, I started off working at one of the vendor companies, developing catastrophe models, which obviously was a great start into the career. Understanding the background of how to assess these types of risks, and my career progression has been pretty much in that field since. From, as I say, from developing the models to then moving to an insurance company, which is a risk carrier taking on the risk. So more about understanding the risk accumulations, portfolio management side of things, reporting up to the management boards, so that they can assess and understand to what extent then that needs to be further mitigated from a reinsurance point of view. And ultimately I've ended up as a reinsurance broker, which is the intermediary with between an insurance company and a reinsurance company. So it's been over a decade now. It's been quite an interesting career. As I say, it's something where you always learn, new things. It touches on so many different disciplines. So kind of landed there by accident. As you said, it's always interesting to to find out and hear how people have started in their careers, because originally my background was geography. It's my bachelor's degree, and remote sensing and GIS pretty much.
Great, thanks, Tina. Yeah, it is really interesting, people's different backgrounds, and obviously we've spoken before, but just for people listening or watching, yeah, certainly my background was in cartography, so professional map making, and sort of fell into GIS, and it's people have different starting points, don't they? So it's really interesting. One of the I know one of the topics we were going to talk about, and I'll just get straight to it, obviously around data quality, but before we maybe talk about data quality and aspects around that for reinsurance purposes, I just wonder what kind of outputs you produce. I mean, maybe I'm asking an obvious question. Obviously, there's map outputs, but what other kind of deliverables or outputs do you produce and use for yourself and others to make decisions with?
Yeah, no, that's a good starting point, and the output again varies on the type of decisions that you're looking to make. So there's certainly a map component. I mean, if you start off from a insurance point of view, if you're an underwriter and you want to understand sort of how risky that location is that you want to underwrite, say it's a property for household insurance, the sort of things that all of us potentially purchase, is understanding that in the context of various risk factors. So if you think about natural catastrophes, how likely is there going to be a flood? So you might compare that against flood hazard maps. So the geography component is really important, and the visualization, I think, always helps with conveying information to especially sort of non-experts as well. But ultimately, I think there's, from a catastrophe modeling point of view, there's sort of a lot more around understanding the risk metrics and the likelihood of a loss occurring and the severity and the cost associated with that. So a catastrophe model, in essence, links basically what we call the exposure. So that's sort of the location information, say take a property, the type of property it is, the value, etc., and puts that into a model in relation to hazard. So whether that's, flood footprints, inundation, the depths in terms of severity, etc., or a windstorm, wind fields, it obviously depends on the type of peril you're looking at. And of course, the sort of insurance terms and conditions as well, what we sort of call financial module. If you think about, you may have to pay a deductible, if you have a car insurance, your excess, that sort of thing, or what's the limit. And all of these things are combined with sort of statistical models. It's in essence, calculating the probability then of an event happening, the occurrence and the severity, and that produces various sort of statistical outputs. So what we call like an exceedance probability or return period of an event happening, sort of 1 in 100 years, which is basically a very small probability of an event happening in any given year. So it's not predicting anything, it's just kind of giving you a financial metric of assessing what the likelihood is, and then the associated cost. So that can be also looked at, yes, I say in an annual form, sort of what's the average annual loss. And these are the kind of metrics that feed into further sort of actuarial models to then really, understand, what's the risk associated with that, and at what point do we want to mitigate that. So it goes quite complicated, but it's a way and means to assess that risk and then make those decisions of, how much you want to mitigate or whether you even want to underwrite it in the first place. I hope that makes sense.
It absolutely does to me. Again, if the audience is broader, but I think I'd just point out it's abundantly obvious, no doubt, to most people when we talk about modeling what we mean data modeling. But you'd be surprised, Tina. A lot of my time I talk about models and modeling, and what we simply mean with a lot of people I talk to in the built environment is a 3-dimensional geometry. And not a data model. So I just thought I'd point that out for the handful of people maybe listening or watching, that there's data modeling, which you're talking about, and then there's modeling as in modeling a single building. And of course there's an overlap, there's a continuum. And I think I think what is clear to me is data quality is really important across whatever domain people work in. And Have you got anything just to say about how you maintain, so you personally or the organization or just generally in your sector, how you maintain data quality and what some of the sources of data are? So just tell me, what's your approach to data quality and how is that handled in your sector?
Yeah, so again, that depends sort of which which part of the sector you're working in. If you are a sort of direct insurance company, then of course you collect the data, from your policyholders, and theoretically more could be done there to collect more detailed information and capture all of that. And third-party data providers are sometimes used to augment information. Again, when it comes to underwriting, you might want to use other data to help understand, as I say, like flood hazard maps, or even what's a crime in an area. It could be all sorts of things. And so the quality there is obviously sort of the data capture at the initial stages. But if you're working at a broker like we are, or a reinsurance company that sort of takes the data from, kind of third parties, from your insurance clients, then you obviously dealing with a different level of data that's kind of either already aggregated, or it's a large data set. So if you think an insurance company might have a whole portfolio of properties it insures against natural catastrophes, for example, and that gets passed on, right? So let's take the UK, for example. So you might have a portfolio spanning most of the UK with, simple information. I mean, the most basic that you need for modeling is obviously the location information, and the more granular that is, the better. So you ideally want coordinate information, especially if perils like floods that we call quite localized, because they're quite quite granular in terms of where flooding occurs, versus a windstorm where you've got a wide wind field where perhaps it's enough to know a postcode of a property. So it really depends, again, on the peril and the application, but it's a bit of a data chain, I suppose, as it goes through the industry, from the point of underwriting, feeding through to, assessing your portfolio as a whole, understanding your exposure accumulations, what you might pass on to a reinsurance broker to quantify the risks for reinsurance purposes. And the challenge there is, as I said, you're dealing with large data sets, potentially not as well captured data. And there's also, of course, a challenge with GDPR in terms of what can be captured and passed on. So I think the added challenge as well is, I mean, obviously we're talking here about the UK, but if you think about at an international level, I think the UK is very good with capturing information. If you think about the National Mapping Agency and what's available, obviously not everything is for free. That varies as well by country. I think in the US there's also a lot more sort of freely data sets available, well captured data. And then if you go to somewhere like the Middle East, where the data is simply not there, so you get very aggregated data, and then we try to again improve that data, so disaggregating it or augmenting it. So the data quality is very varied, and the better the data, of course, the better, the more accurate your model. It's the old saying: you put garbage into a model, you get garbage out. So data is a challenge. We do a lot in really auditing what we're doing, how it's captured, playing it back to our clients to make sure they're happy with what we're feeding into the models is appropriate, because ultimately that impacts the outputs.
Thank you, Tina. And another, I mean, leading on, I guess, from data quality is sort of metadata. I know this is sort of an old conversation, particularly in geospatial and GIS sectors, but there's a lots of individuals that aren't familiar with metadata and certainly don't manage it, or they might use it and they're not aware. But how is metadata handled? Do you have a large catalog? Do you specify, or does your organization specify specific metadata when you acquire data? But what do you want to say about metadata as a geospatial professional in part?
Yeah, no, it's data about data, isn't it? Metadata. It's ultimately, I think it does play an important role. It's perhaps something that is underutilized in understanding the data you have, and as you say, cataloging it. I think there's more efforts being done in terms of collecting data, understanding the data that you have, creating the so-called data lakes, or the centralized repositories of data, so that it becomes more accessible. You can derive insights from it, and for that, obviously, it's very important to have sort of the quality information about the data you hold. But yeah, I think from my own experience, that is still largely underutilized. I think it depends on the data maturity of the organization as well. I mean, ourselves, we are still on a journey to implement better ways of deriving insights from data, because it's just, all organizations sit on data, one way or another, whether you know it or not. You've got data. I mean, I think it's been termed that data is sort of the new oil of the industry, right? It's just, how do you make the best use of that data, ensuring back to the data quality that what you have is usable, because otherwise it can also drive false insights, or error propagation, which is also obviously a term that many of sort of geospatial colleagues would be familiar with, is as understanding that data. And I think for that, metadata plays a hugely important role. But yeah, as I say, I think it's still largely underutilized.
Yeah, I would absolutely agree. I guess that was partly a loaded question to get people to think about it. It's not talked about enough at all in any domain, I would say. But yeah, thank you for your point of view on that. We're talking about, obviously, today, catastrophe modeling, and that's what you do. But as someone who's not that familiar with it, I've been peripherally involved a few times in my career, but are there standards for it? Is there for example, is there an international standard for a cat model schema, for example, just for people that are completely new? And if so, what are they?
No, I think the elements of that, I think there have been efforts in the industry to derive sort of a more standardized approach. I think it's sort of in pockets. A lot has been driven out of the UK from Lloyd's of London, just simply because of the history and how far back that dates, with the inception of sort of insurance, and how that originated with sort of marine insurance. They have certainly created a number of sort of documents, outlining best practices and what's required for exposure management and modeling. So that's always a good starting point. There has also been sort of an industry initiative to promote more the open source of catastrophe modeling. So it's the OASIS loss modeling framework. So to have more sort of an open access platform where vendors can have their various models being run on, and that in a way promotes that sort of unified data schema. But in terms of schema, I think that data schema itself, that's been largely driven by sort of the original vendor companies that kind of started off the catastrophe modeling, so the likes of RMS, VRisk, and a few others. I mean, it's not such an old discipline. I think sort of the catastrophe modeling started really taking hold from sort of the late 1980s, early 1990s, sort of moving away from spreadsheets, using the more sort of GIS components and statistical modeling, etc., and then to formalize that and to bring together the various disciplines that have been talking about. So they've kind of become the currency in the market, if you know what I mean, those kind of models and the outputs and the way the data is captured, which ultimately, are databases, and how that information is represented and then feeds into the model. So I guess you could call those almost standardized. But yeah, I think it's a bit of a fight on which vendor company is trying to establish itself as the standard, or promoting this sort of open platform where other vendors can put their models. So I think that's where it's a bit of a competitive space. But I think, as a reinsurance broker for us, we need to be able to deal with all of these vendor models, because we need to run them for our insurance clients. We evaluate those models back to what we call the view of risk, to understand, which model, what are the strengths and weaknesses, and what they're most which are most appropriate for our client, which links back to the research and academic inputs that we bring through the Gallagher Research Centre. And yeah, because of that, we sort of centralize that and are able to deploy all of these models and apply the data accordingly. But to your point, I think more can be done, especially from a global point of view. I mean, even thinking from a hazard point of view, when it comes to modeling, it's always a challenge, right? Because you've got different data sets, different data standards, quality, and you're trying to fit that together, especially if you want to have something like a global catastrophe model, which I know some vendor companies are promoting as well, whether it's like a global flood model, etc. But you also need global data sets and consistent data sets for that. And I think that's still quite a large limitations that we're facing at the moment.
Great. Yes. Thank you, Tina. And I was just about to ask you, and you sort of, the last phrase you said there sort of talks it up actually, is how do we sort of touched on it. You talked about the type of data sets you use, but to ask you directly, how do you, as an organization, address data availability or gaps? So maybe if you don't mind, and if you can say, there might be commercial sensitivities about, is there a specific example where you've used I don't know, for example, an open source data set or some other to fill gaps? Is there an example you could give?
Now I'm just thinking about that question, because ultimately, again, from a broker point of view, we ultimately take the data right from our clients. So it's not like we're collecting our own or doing our own thing as such. So we take the data from our clients, we advise our clients on limitations in their data. As I say, we do audits and data quality checks, and give them advice if they're lacking certain information or what they could do to improve. Yeah, sorry, what was the question again?
But you're not in that, so data gaps, but the implication, wrongly perhaps, is that you would be sourcing data. So for example, I have a first-hand experience of using OpenStreetMap, for example, to capture building footprints in somewhere in another country in Southeast Asia. Now, sounds like I've asked the wrong question, because you're not capturing primary data. So is that the case?
Yeah, no, we don't capture primary data. However, as I said earlier on, we do develop our own catastrophe models as well, and for that you also need data inputs. And yeah, absolutely, if there is open source data available for commercial use, then we would use that, or maybe we purchase certain data sets if we need to, say, develop a catastrophe model that we then apply to our client portfolios. Or we may also, we may purchase some data sets to augment data, but it all depends on ultimately the business case, the value add, and how that fits in with our client needs. I mean, open source, it all depends on sort of the commercial terms of usage for these things. I mean, that's one of the challenges that we found as well as insurance industry, is that because there's a lot of initiatives out there for risk mitigation in the humanitarian sector, right? Where, of course, data, information, models are freely available. I mean, take for example, Copernicus on event response, and obviously we use certain elements of that as well to advise. But there is obviously the challenge with that we are a commercial organization, and therefore you do need to obviously bear in mind the terms and conditions of what you can use. Whereas if you're in the humanitarian sector or public sector, then those informations are obviously a lot more readily available to support sort of risk, emergency response and that sort of thing.
Great. Yeah. Thanks, Tina. Yeah, there's certainly that challenge, like you said, commercially or not. Certainly throughout my career, and this won't be the case in insurance or reinsurance, but in my career, I've just been given aerial imagery multiple times with no metadata. I don't know what the source is, from a client, and they've said, "Oh, can you use this?" Well, I don't know the year, I don't know the age of it, but I also don't know the terms and conditions of usage. And I'm sure people with a geospatial background will understand what we're talking about. So it goes across many domains. Just maybe moving away from the actual data, technical side of the data. Just I know one of the things we're going to talk about is about a data culture, creating a data culture, best practice. I mean, that's obviously implied with what we've been talking about, but what does a data culture mean to you, and how do you, again, for people that maybe don't have a data culture as far as it is, how do you foster one? How do you create one?
That's an interesting topic, and I think that relates back to what we call the data maturity of an organization. And as I alluded, I think we are ourselves on a journey. Within the analytical departments and the function, of course, we are all sort of, data analysts, scientists with sort of a data background. So I would say we have quite a high sort of understanding of data and the importance, but that's not necessarily the case across the entire organization. If you think about, again, from a broking point of view, we have salespeople, right, who link up with insurance companies, who are reinsurance buyers, and obviously trying to to sell us as a broker to support them in placing their reinsurance purchase. And whilst they obviously use the outputs of that data as a sort of stakeholder, I think, understanding really what goes into the models in creating those outputs. Sometimes there's maybe a lack of understanding or lack of education, and also how much effort it takes, what goes into it, what's required, what it means in terms of the accuracy or uncertainty. So there, I think more needs to be done. Also thinking about sort of the data science aspects, driving. There's a lot of talk about driving insights from data. Obviously, in the classical sense, what we're providing, that's well understood and known. But there's potentially more that we can do from the data that we have, sort of thinking outside of the box, what could support our clients. And there, I think it's also being open-minded to exploring, to visualizing, to identifying how data can play a role in relation to key sort of performance indicators of the business, sort of aligning that to the business goals. So so I think data culture takes a bit of an effort to build and promote across the entirety of an organization. I think more needs to be done on sort of educating on that topic. As you say, we talk about metadata, people not really understanding maybe what that is. But also how we're training up our analysts, the next generation of employees. Thinking about our graduate program, for example, data is not explicitly part of the program as such. We obviously teach all of the various aspects across our business, the different functions, so that our graduates get a sort of holistic view as they're starting off in their career. But again, more could be done, I think, on data, how those roles are defined. I mean, organizations are doing more and more on that. I think we're seeing more and more roles popping up in the industry. Those roles obviously need to be clearly defined. The functions, whether it's a centralized functions or whether those individuals sit within existing teams. So it's not something I think that we have solved yet. It's, as I say, we're on a journey to develop the data culture, but I think it's very important given that data is just central to all of the activities that we do and many organizations do.
Yeah, absolutely. It is central, and we need it, particularly for our kind of roles. And I do see almost a split, if you like, certainly with. For example, in the UK, there are lots of data, they're calling it DDAT, and I use that for the promotion of this podcast as well, digital data and technology roles. And you've mentioned some there, like data scientist, data engineer. But then I can talk to other people and they don't understand basic concepts. So there is this sort of split, isn't there? Very technical people writing code or doing whatever they are and looking at AI training models, and and then at some peripheral level, most people don't understand the value of data. Have you got, just as a direct question, do you, says personally, it's no reflection on your organization because there might be a formal stance, but do you personally see value or if someone were to ask you, which I am, is there value in data, digital data itself, do you think, or in its application? Slightly a bit of a trick question. I get answers both ways. So what's your interpretation? If someone said, is there value in data, what would you say?
For me, it's an absolute yes, right? Because we work with data. It feeds into our models. It's the fundamentals of we would do in terms of understanding, quantifying, the risk. I think the concept of, as you say, data scientists, data engineers, that perhaps is a bit more new. I think in our industry, traditionally, of course, we have actuaries, we have catastrophe analysts. Those are sort of the well-known types of analytical roles to quantify the type of risk, and especially actuaries. I mean, the actuarial program of study. It's all related to obviously statistical analysis and understanding. But I think there's also a role for data scientists in the broader sense, to work with data more broadly speaking. So this is what I've been alluding to in terms of driving data insights. If you have any data in a digital form, can you identify patterns? Can you identify trends? I mean, for us specifically, I mean, we've been looking at all sorts, whether that's understanding how your resources are allocated. So as I mentioned, I look after the international catastrophe analytics, which consists of the various business units, EMEA, Asia Pacific, etc. And those are separate teams, and there can be a lot of duplication or work being done in silos. But if you start looking at it more holistically, and perhaps the data that is captured, and this could be any sort of data, right? It's just understanding how our resources are deployed, how much time do we spend on a particular client versus the income that generates. So there's sort of even just understanding the efficiency side of things is a use of data, for example. Then other examples could be just creating, again, visualizations, dashboards, based on sort of natural catastrophes and data that we've collected or that's available, to visualize, what are the risks across different regions. So for me, I mean, and I think in the insurance sector, generally speaking, data is fundamental to what we're doing, but perhaps, more can be done to derive information from data compared to what we've been doing in the traditional sense.
Yeah, thank you. And obviously, because what you do is data centric, it's you say yes, obviously, for data having value. Surprisingly, some people say no. They say it's only when it's applied. I mean, there's semantics, but the reason I ask is asset management, as in physical asset management. I don't mean the physical asset management. Physical asset management. There is a standard which I'm sure you'll be familiar with, ISO 55000 series. Anyway, it can apply and does apply to data for not non-intangibles as well. So there's this interesting link there where the data might be about physical assets perhaps, but you can apply the same rigor framework to managing the data itself, which I slowly seeing that in infrastructure sectors, for example, rail. But I just thought I'd give that as an aside. But that's probably why I'm talking to you. I sort of fell into that side of it, where if we don't have the data, we can't manage the physical infrastructure. It's sort of a circle, isn't a circular sort of feedback. But anyway, but back to reinsurance, I certainly would be interested, and you may have touched on them already, but certainly with your the work that you're doing with research, I just wondered if what you've seen, how you've seen things progress, say in the last 5 years, or even just in the last year. Where have we improved, or where have you improved as a sector, the way things are done? What have you seen in the last 5 years? I know it's a very open-ended question, but for someone on the outside, how are things done now that they, more efficiently opposed to 5 years ago, for example?
Yeah, I think thinking about this in a broader sense, I think there are probably various areas where we've seen progression. There's certainly element on sort of the data processing, because for catastrophe modeling, that can be quite data intense, especially if you have a large geographical domain and sort of a high resolution peril, like flooding, where you need really granular data and a lot of number crunching, where it would have been challenging 10 years ago to model, say, the whole of the US in a very, very detailed manner. So I think the sort of computational power and aspects around that have been improving. I think that's where AI is also starting to play more of a role in terms of dealing with larger data sets, the data interpretation, identifying patterns, and certainly there's a lot of research going on at the moment. I mean, it's a bit of a hype, of course, as well, with AI and how that can be used, for example, in climate modeling to improve predictions, but also I think on the exposure side, where we've been much better at capturing data, as I said, sort of the understanding of what's required by our sort of clients, and then capturing that data and what feeds into the models, augmenting that data, processing we talked about. I think the other thing as well is, of course, the types of risks and trends in risk management are evolving as well. So if you think about cyber, so again, thinking about the digital age that we're in, cyber wouldn't have been a huge topic. I mean, 5-10 years ago, it would have been on the cards, called as an emerging risk, right? But now cyber is obviously is up there with other perils. There's obviously still the challenge in quantifying cyber risk, because it's hard to define. There haven't been that many cyber attacks that provide the precedents and how you can quantify. So there's more sort of scenario-based approaches. So there are challenges with that, but it's interesting how the risk landscape is evolving with the types of risk we're seeing. So of course the traditional risks around natural catastrophes, they're still there, and some argue those are on the increase because of climate change. That obviously that depends on the type of peril that is, and the geography and etc. But of course those have been the first and foremost thing that there was an interest in modeling. Cyber, geopolitical risks, as we're seeing a lot at the moment. It feels like we are in a very sort of unstable environment at the moment. If you think about all of the issues that impact us globally, from post-pandemic, the economies, living crisis, the various conflicts, and trying to then to ensure or mitigate against those is a challenge. That's something that we've seen evolve as well, and I think again data will play a role in this, because it boils down to how can you quantify those kind of things, and that's difficult when it comes to political risk, cyber risk, etc.
Yeah, certainly cyber you mentioned, and that's I mean, it's a whole podcast on its own, isn't it? But it's of course, probably like most people, I think of climate change and other sort of natural perils, and even as someone who works in data and information management, I wouldn't necessarily think of cyber immediately when we talk about reinsurance. So that's really interesting that you mentioned that, and I mean, again, that's probably a topic on its own to think about what the potential challenges are. But one thing I just made a note of as you were talking, and this is for the benefit of people that aren't familiar, parametric insurance, is that something? What is it, first of all? What does it mean? This isn't a trick question. Remember, I'm not a specialist in these things. Oh, and do you see more clients ask for this? And is this something that you deliver as a service?
No, we do. I think it's understanding what the purpose it's used for. I mean, that's predominantly used in regions where perhaps there isn't a established insurance sector or framework. So this is where sovereign countries are looking at ways and means to protect themselves against natural catastrophe perils, but they may not have the sort of infrastructure in place from an insurance point of view to do that sort of themselves. So that's where parametric insurance can come in to support that in a more simplistic way, because parametric in essence means where you have a trigger, which is basically a defined parameter that triggers the insurance payout. So if you think about, for example, a simple one to define as an earthquake. So you could have an earthquake happening, certain magnitude, and if it reaches that, then that parametric trigger is initiated, and that then causes the payout. And that's obviously all set up in advance with the financial mechanism in play to pay out. And that could involve obviously reinsurers, but it might involve donors as well. I mean, like the World Bank, for example, to help fund those sort of things. And the advantage is that it basically provides a quick way of providing disaster relief and the financial support that countries need to then to initiate their disaster response and to have that payout happen.
Yeah, I've certainly come across it with work with the World Bank, but yeah, I hadn't heard the term before. But I've since, it's like when you've heard these things, I since keep hearing it in other domains and things like smart contracts. I know they're not the same thing, but there's a conceptual similarity perhaps for triggering and then events, which of course is what you're focused on. But I mean, look, I guess looking forward, what do you see? We've talked about how things have progressed, but what's the one or two things that you see? I mean, is it AI, or is there something? Maybe give an example, if you would, of something perhaps that we wouldn't be necessarily familiar with. Is there any emergent technologies or techniques that you can talk about that maybe are surprising or surprised you, or that have come across from a different domain?
Something to think about. I mean, it's always interesting to look beyond your own field, right? To kind of see if other sectors are doing something that perhaps you haven't thought about, you could use. And that's certainly where sort of the Gallagher Research Centre comes in and plays a role. I think in terms of trends and what's to come in the future, there's definitely still a need to improve modeling, especially for certain perils. I think climate modeling is still a big area where more advancements are constantly being made and still are to be made. I've touched on how artificial intelligence is now being explored in those sort of things. We see more of that. It's because there's so much that we don't understand yet. I mean, climate change is a clear topic here, right? It's understanding the future of climate when we're not even perhaps fully yet understanding the current climate or the climate variability, the natural variability that we're seeing. So I think there's a lot more room for research and development in those models. There is, as I've touched on, sort of the emerging risks and kind of anticipating, perhaps. It's always easy in hindsight. Pandemic has happened, right? But we wouldn't have thought about that perhaps in great detail beforehand. So I think this is a challenge for us as a research center, is where we want to link up with academia and the trends and what they're researching and what that could potentially be, relevant for us in the insurance reinsurance sector. So traditionally speaking, I think we've always collaborated quite a lot with academia, and that's an exciting aspect. But it's ultimately linking that with what the business needs are, and that could be across what we call different lines of business. I mean, talked a lot about property, natural catastrophes. We touched on cyber, but there's other insurance, marine risks, how those can be modeled better. Life and health, for example, casualty, motor. I mean, there's so many different lines of businesses that traditionally perhaps we wouldn't have looked at in great detail for sort of research and modeling. So yeah, I think it's an interesting space to watch with all of the things, cyber, geopolitical, climate change, technology, data capture, artificial intelligence, just to name a few top of my head, that I think will shape the way we do things longer term.
Yeah, great. Thank you. The point you make about looking across other fields or domains or industries, that's where I don't see enough of that. Obviously, we're talking about reinsurance today, but just generally, I will, for example, go to just water infrastructure or energy sector, or just, even if I have or haven't worked in them sectors, because for this cross fertilization, I mean, sort of pre-COVID, a lot of people don't go to events now, but are there events for reinsurance? Do they talk about data enough? What kind of industry events are there that do this?
Yeah, so certainly for anybody who's interested to find out more about the sector, there are certainly events hosted by the vendor modeling companies themselves, even Oasis that we've mentioned. They're not for free, but if there's a keen interest to understand more about the catastrophe modeling specifically, you can look at the vendor companies, RMS, VRisk, Oasis, the sort of thing organizations we've named. There are, of course, reinsurance, sort of what we call rendezvous, but that's really more for the reinsurance, clients and reinsurers and brokers to come together to, discuss sort of the upcoming renewals. What we mean by renewal is when an insurance contract ultimately renews, as you would know from yourself when you have an insurance policy. So that there are market gatherings to talk about the trends, the costs and pricing and how things are evolving, and that's a challenge that ultimately we have as a reinsurance broker, is to be the mediator between the insurance company and the reinsurer taking on the risk, and how much that will cost ultimately. But yeah, I mean, in terms of events, there's so much crossover. I think we've also been to a number of sort of data conferences. I mean, there's so many of them. There are also lots which are free, but then you get a lot of sort of vendor companies there trying to sell stuff to you. But it's also worthwhile to go to data conferences, I found, especially listening to the data challenges across different organizations, coming back to the cross-fertilization and just hearing similar challenges that other sectors have around data as well. You actually, I found it surprising. I've been to a data conference just to kind of hear similarities and challenges, but also sometimes to hear how they approach things, on how they centralize their data, or how they deploy it, how they drive data insights. So there's a huge amount that you can learn as well. So I recommend data-related conferences as well. And I think there are webinars out there. Certainly, we've been promoting this through the Royal Geographical Society, where I have co-founded a professional practice group in disaster risk management, which is now passed on to others to run. But the idea behind that as well was to just make the sector more accessible to others, and not just the reinsurance sector, because disaster risk management spans across multiple sectors. As I said before, it's it's governments, it's your public sector, it's emergency responders, humanitarian sector, etc. And how those different stakeholders work with risk mitigation and the goals and purposes they have. So again, the idea there was to look at best practices and similarities or differences, and and to drive insights. So there are a lot of free sort of webinars as well that we do, for example. And Oasis, we talked about that. I think they're a great initiative to promote sort of the open source modeling and understanding of catastrophe modeling, and ultimately the various sciences touch on that as well. I mean, for natural catastrophe modeling, if you think about it, you've got meteorology, seismology. It touches on so many different things. Computer science, cyber risk. That's why it's such a great, fascinating field.
Thank you so much for your time and insights, Tina Thomson from Gallagher Re. Thank you very much indeed for your time.
Now, thank you very much, and I hope it was of interest to your listeners. Thank you.
Great. Thank you.